So what's good, TMG fam? Now listen, they got the audacity with some of these titles, bro. The real audacity of them. Title of this video is, Humanity Isn't Ready to Hear This Yet. Says who? Oh, no. We gonna check this out. So if you're new, hit that subscribe button. Join the fam.
A long time ago, there was a very big bang, and thus, space was created. Then, a while down the line, human beings showed up on Earth, and we've tried ever since to figure out what is really out there in the universe. But what is space, really? In astronomy and cosmology, space is the vast, three-dimensional region that begins where the Earth's atmosphere ends. The universe is all of space and time, and it doesn't end, but is somehow simultaneously expanding. It is mind-boggling. From the largest and most powerful object in the universe to the discovery involving a mass of water that changed our understanding of the history of the universe, here are 20 surprising facts about space you didn't know. Number 20. Do aliens exist? When I say aliens, I'm sure your mind goes straight to all the depictions of the little green man that Hollywood has given us over the decades. Or maybe the terrifying version with huge black almond eyes and the eerie long limbs and fingers. The fact that some UFO chasers have falsified evidence also makes people skeptical about the existence of extraterrestrial life. But let's be real.
That's true. We don't know who to believe with all the falsified evidence and lies that's been given. We don't know who to believe.
Real here. The universe is so extremely and painfully enormous and vast, it would be kind of innocent to believe that we are the only intelligent beings out there. And after the classified footage released by the Pentagon's Aerial Phenomena Task Force, well, things get a little too real. This is why humanity isn't ready to hear this yet. When there's in the sky an unidentified flying object that not even the United States government knows what it is or where it came from, chances are it does come from our beloved planet Earth. And according to the New York Times, there have been over 120 incidents of UFO sightings from the past 2 decades alone that not even the Pentagon's Aerial Phenomena Task Force can identify. But what does this mean exactly? Well, it means that the possibility of mankind being alone in the universe is quite dim, and moreover, there seems to be overwhelming evidence that they have been here in various times already. Before we go on, like this video, smash the subscribe button and click the notification bell right now, or this centipede will crawl on your face when you're sleeping. Number 19. Galaxies collide. The collision between the Milky Way and Andromeda, the 2 largest galaxies in the local group, is an event that is believed will take place in the future, and in which the 2 galaxies will eventually merge and become a much larger, very large galaxy. Scientists believe it'll possibly be a spiral galaxy. Although it's known that both galaxies are approaching at a speed of around 300 kilometers per second in reference to the Sun, and that they will approach each other in approximately 3.8 billion years, something confirmed by the Gaia probe in 2013, the only thing that's clear is that, with great probability, sooner or later it will happen, and thus, recent research carried out with the help of the Hubble Space Telescope not only confirms this scenario, but also suggests that the Milky Way and Andromeda galaxy will come very close within 3.87 billion years, and that the final merger between the 2 will take place within 5.86 billion years. Over the years, the Andromeda galaxy will seem to increase in size as it gets closer until the moment arrives, in the event that both galaxies were to collide, in which the sky would be dominated not only by the diffuse band that is like our galaxy is seen, but also by Andromeda, which would probably appear similar to how we see it today, only much larger, enough to be able to see its spiral structure with the naked eye.
That's cool when they talking about eons and as my grandma would say, eons away, right? I need to know what's gonna affect us in our lifetime, possibly. You know what I'm saying? That's cool and all, but where's the stuff that we should be worried about?
Impressive sight would last only a few million years, a short time in astronomical terms, after which Andromeda would turn on its edge and its gravity, combined with that of the Milky Way, would begin to act the closer they were to each other. Number 18. Space is completely silent. If we were to ask any person of average knowledge to describe space to us, they would probably mention 3 features. It is dark, cold, and empty. Well, actually, the first 2 properties are consequences of the third. Although there's a lot of light circulating through space, the almost absence of gas molecules in its path results in a black background. And since heat is molecules in vibration, the thermal sensation in practice is intensely cold. Another consequence of the vacuum is that space is also silent. As the tagline of the movie Alien said, "In space, no one can hear you scream." The reason for spatial silence is that sound waves need a medium to propagate. For centuries, scientists postulated that space must be filled with a medium they called ether, which would allow the propagation of light. But the ether does not exist. Electromagnetic waves can be transmitted through a vacuum thanks to the fact that they carry an associated particle, the photon. And this does not require a substrate on which to travel. The transmission of mechanical waves, such as sound, depends on the pushes that the molecules give each other until they reach the eardrum. For a wave to propagate, the distance between the molecules must be less than the wavelength. The less dense the medium, the longer the wavelength must be for sound to propagate, and thus the frequency is reduced. Below about 20 Hz, the sound is too low for humans to hear. We call this infrasound. Number 17. Cold welding. The anecdote I'm about to tell you took place at the Gemini 4 mission when NASA sent Ed White as the first American astronaut to attempt a spacewalk. After thoroughly completing and enjoying his trip outside the cabin, White had to return inside the spaceship. But alas, the hatch wouldn't close properly. Now, if your car door refuses to close, it's a real pain in the neck, but the door on a spaceship? Yeah, that's a little more alarming. It was a real chore for the astronauts to wrench the hatch closed. And in assessing what happened, NASA engineers started wondering, had the hatch undergone cold welding? But wait, don't you need like a whole lot of heat to weld metal? As it seems, in space, if two metals come into contact, they can actually fuse together without the need for heat or melting of either piece. It turns out that cold welding was not the issue on Gemini 4, but apparently it is a real problem for metals they send into space, and it's happened on other space missions. Number 16. Jupiter's.
I think it's always fascinating. Excuse me. It's always fascinating that the astronauts up there have to also be their own mechanic. So anything goes wrong, they have to be responsible and fix it. You know what I mean? Anything that happens. So they got to be trained for any type of scenario. You get what I'm saying? That's just fascinating to me.
Great red spot is shrinking. The Great Red Spot, the one that you can see in most pictures of Jupiter, is simply a high-pressure system located in the planet's southern hemisphere. In other words, it's a powerful anticyclone that swirls counterclockwise around its center. Also, scientists sometimes describe it as a pancake due to its shape and structure. Isn't that wholesome? But don't be fooled by its charming and cute nickname. The Great Red Spot is a very violent storm that rages at about 430 to 680 kilometers per hour. Researchers have been tracking the pancake storm for a century and a half, but no one knows exactly when it was formed. Everything points towards it being much older than the earliest records indicate. And though the spot has become known for its immense ferocity, the size of its bite may be changing. Like all storms, even the ones that occur here on Earth, the spot is dynamic. Its constitution is constantly fluctuating, and apparently, as in recent times, the storm is contracting. So much so that some scientists believe that the Great Pancake may not exist for much longer. The winds in its outermost stretches are speeding up, and its shape is rapidly changing, becoming taller rather than wider. Wow. Number 15. There is an uncountable number of stars in the known universe. Okay, so if I tell you that we don't know how many stars there are in the entire universe, that shouldn't come as a surprise. But the fact that scientists can't even count—
I don't think I've tried to count stars since I was a kid, bro. To be honest with you. Sometimes I can go a while without even looking up. You know what I mean? Looking up in the sky. And then when you look up, you're like, dang, I ain't looked up in a while.
The stars in the known universe, that gives you an idea of just how vast space truly is. It's surprisingly difficult for scientists to give a fair answer to the question. The fact is that stars are not scattered randomly throughout space. They are gathered together in vast groups that we call galaxies. Our beloved sun belongs to a galaxy called the Milky Way, and astronomers estimate there are about 100,000 million stars in our galaxy alone. Outside our cosmically not-so-big Milky Way, there are millions upon millions of other galaxies, some a lot larger than ours. So basically, trying to count the number of stars in the universe is like trying to count the number of grains of sand on a beach. And in fact, that would be an easier thing to do, but we do have a representative number, and here's how they calculated it. There are some like 10 to the 11th to 10 to the 12th power stars in the Milky Way, and there are perhaps around 10 to the 11th or 10 to the 12th galaxies in the universe. So by multiplying the two numbers, we get something like 10 to the 22nd to 10 to the 24th stars in the universe. Number 4.
Sounds about right? Sounds like the math is mathing, right? We don't know. We just got to go along with it. How can we, you know what I mean? What can we say? We just got to go along with that.
13. 1 day on Venus is longer than 1 year on Earth. You've probably learned in school that 1 day on Earth corresponds to the amount of time it takes for the Earth to completely spin around its own axis and make one full rotation. It's called a sidereal day, and here on our blue planet, a sidereal day is almost exactly 23 hours and 56 minutes. Earth takes a lot less time to rotate on its axis than it takes to rotate around the sun. That's why 1 day is a lot shorter than 1 year. But for Venus, things are quite different. In fact, it takes the planet of love and beauty a whopping 243.025 days to rotate once on its axis, which is the longest rotational period of any planet in our solar system. Also, it rotates in the opposite direction in which it orbits the sun. In other words, Venus has a retrograde rotation, which means that if you could view the planet from above its northern polar region, you would see it rotating in a clockwise direction on its axis and in a counterclockwise direction around the sun. Because of this unique behavior, if you would be standing in Venus's surface, the sun would rise in the west and set in the east, although the sunrise would take about a year. Number 13. Uranus spins sideways. The first planet found with the help of a telescope, Uranus was discovered in 1781 by astronomer William Herschel, although he originally thought it to be either a comet or a star. 2 years later, the object was universally accepted as a new planet, in part due to observations by astronomer Johann Elert Bode. The seventh planet of the solar system has a characteristic that makes it unique. Uranus is about 4 times as wide as Earth, with a radius of 25,362 kilometers.
I know now a lot of y'all thinking just like I am. I know y'all are. I know y'all very well, man. We've been rocking for a long time. A lot of y'all are thinking, okay, cool. So who named it? Who named it? Who came up with that name? Did he do it? He's responsible for that. I was thinking the same thing.
As wide as Earth, with a radius of 25,362 kilometers. If Earth were a large apple, Uranus would be the size of a basketball. Like Venus, Uranus rotates from east to west, but Uranus is unique in that it spins on its side. It is the only planet whose equator is nearly at a right angle to its orbit, with an inclination of 97.77 degrees, possibly the result of a collision with an Earth-sized object a very long time ago. This unique tilt causes the most extreme seasons known in the solar system. For nearly a quarter of each Uranian year, the sun shines directly over each pole, plunging the other half of the planet into a dark 21-year winter. Number 12. Venus is the hottest...
Wait. 21-year what? Yo, enduring that? No, thank you.
Planet in the solar system. You will never want to visit Venus, I assure you. Its temperatures are hot enough to melt lead. This is perhaps one of the reasons why it's considered the hottest planet in the entire solar system. Venus is the second planet in our solar system in order of distance from the sun. It's described by many scientists as hellish. The conditions that distinguish Venus suggest that it's a place where no one could survive. Earth's sister planet boasts a stifling atmosphere made up of 96% carbon dioxide, where temperatures average 462 degrees Celsius, supplemented by a toxic plume consisting of rain clouds of carbon dioxide and sulfuric acid. And yet, several scientists theorize that Venus was once a very different place, with a cooler atmosphere and liquid oceans on its surface. Geological analyses indicate that the planet planet may have had a lighter, cooler atmosphere and perhaps even supported life. The first theory that was handled was that several million years ago, Venus had been hit by a massive object that slowed down its rotation to the point of reversing it. However, a new theory says that was not the case, as it seems the culprit of the descent of Venus into hell was none other than its own ocean. Astronomers found that ocean tides slowed its rotation by 72 Earth days every million years. Number 11. Saturn has a hexagonal-shaped storm. The Saturn hexagon is a persistent cloud pattern located around Saturn's North Pole. Saturn's polar hexagon was discovered during the Voyager mission between 1981 and 1982 and was observed again on the Cassini mission in 2006. Cassini was only able to capture thermal images with an infrared camera until, in January 2009, the area was exposed to sunlight. A hypothesis to explain this curious phenomenon has been developed at the University of Oxford. The hexagon is believed to form in areas where there's a high latitudinal gradient in the speed of Saturn's atmospheric winds. Similar shapes were created in the laboratory by making a circular tank of liquid rotate at different speeds at the center and the periphery. All kinds of shapes between triangular and octagonal were achieved, although it was observed that the most common shape was a hexagon. The sides of the hexagon are about 14,500 kilometers long, which is about 2,000 kilometers longer than the diameter of Earth. The enormous hexagon may be a little bit more than 29,000 kilometers wide and 300 kilometers high, and it doesn't seem to shift in longitude like other clouds in the visible atmosphere. What does change, though, is its color. The hexagon changed from a mostly blue color to a more golden appearance. Number 10. Rain on Saturn is made of diamonds, not water. Sometimes reality surpasses fiction. The sixth planet of the solar system is made up of an immense gaseous mass, and its environmental conditions and chemical composition are so different from that of planet Earth that the rain is not made of water, but of diamonds. Scientists believe that about—
Yeah, I've heard of this before, but isn't it like grinded into dust or something like that?
10 million tons of these stones are produced in its atmosphere each year. This phenomenon occurs thanks to the combination of methane gas with the violent storms occurring on the planet's surface. The rays of Saturn have very high temperatures. They are 10,000 times more powerful than those of our planet. When they're produced, they break the bonds of the molecules, separating the hydrogens on one side and the carbons on the other. The carbon atoms bond with each other, creating larger molecules that form a soot-like compound. You know, like that black cloud that comes out of the car exhaust and that, as you may have noticed, is very far from resembling a diamond. Molecules that are relatively heavy and affected by the planet's gravity begin to sink inward. The more they fall, the higher the temperature and pressure to which they are subjected, and that's how they become diamonds. Number 9.
I could have swore they said, because you know as well as I do, if there's diamonds up there, everybody who's billionaire, millionaire, high millions are going to be trying to figure out a way. But I think that stuff is grinding it. I have to look that up. I can't really remember what video it is, but I'm going to have to research that and figure it out. That's going to bother me. But yeah, I think it's grinded up by the time it lands or whatever.
Mars boasts a volcano bigger than the entire state of Hawaii. Mount Olympus on Mars is the largest known volcano in the solar system. It's located in the western hemisphere of the Red Planet. Ironically, it is the youngest of the great volcanoes on Mars. It is formed during the last 1,800 million years. The central massif of the volcano rises almost 23 kilometers above the plain that surrounds it. This is equivalent to 3 times the height of our Mount Everest, the highest mountain on Earth. Its caldera is 85 kilometers long, 60 kilometers wide, and almost 3 kilometers deep. You can see up to 6 superimposed chimneys formed at different times. The base of the volcano measures 600 kilometers in diameter, including the outer edge of the cliffs. In total, the base occupies an area of about 283,000 kilometers squared, which is bigger than the state of Hawaii. It's difficult for us to imagine such dimensions. An observer located on the Martian surface wouldn't be able to see the silhouette of this monstrous volcano, even when moving very far from its base. Before being able to appreciate its shape, the curvature of the planet would have already hidden it. At most, a wall would be seen or confused with the horizon line, nor would we see the form of the volcano from the top. Looking down, we would not see the end, since the gentle slope would reach the horizon. The only way to see this colossal mountain is from space. Number 8. The sunset on Mars appears blue. As we all already know, Mars is called the red planet, and this is due to the iron oxide that its soil contains. Its distinctive reddish color is visible from planet Earth. Sometimes you don't even need a telescope to see it. The ancient Romans named it after their god of war, Ares in Greek mythology. The question we ask ourselves then is why its twilights are blue, and everything has an explanation. Colors become more dramatic at sunset, and sunsets from Mars take on a blue hue. But why? It's all due to fine dust, which makes the blue closer to the sun much more prominent. The colors come from the fact that very fine dust is just the right size for blue light to penetrate the atmosphere slightly more efficiently. When blue light is scattered from the dust, it stays closer to the direction of the sun than light of other colors. The rest of the sky is yellow to orange, as the yellow and red light is scattered throughout the sky instead of being absorbed or staying close to the sun. In turn, these images have also shown that the twilight glow remains visible, albeit increasingly faint, for up to 2 hours before sunrise or 2 hours after sunset. This moment is so long compared to that on Earth because of scattered sunlight on the night side of the planet due to abundant high-altitude dust. Number 7. 1 million Earths can fit inside the sun. It turns out that the sun has a diameter equal to about 109 times that of the diameter of the Earth. The maximum circumference of the sun must also be 109 times greater. Suppose two imaginary trains, one here on Earth and one on the sun's surface. Both trains are going at 100 kilometers per hour. It would take the train on the sun 109 times longer to go around it than the train on our planet would take, and it would take almost 5 years to do so. We can form a clearer idea of the relationship between the sizes of both the Earth and the Sun by using a comparison. If we represent the Earth by a grain of sand 1 millimeter in diameter, the Sun will be a huge grapefruit with a diameter of almost 11 centimeters. You can now get a better idea of how insignificant our planet is compared to the Sun. From the point of view of volumes, the difference in size between the Sun and the Earth becomes even more impressive. A simple calculation using the respective diameters as data tells us that the Sun has a volume 1,300,000 times greater than the Earth. It's easy to write this number, but it requires an effort of the imagination to understand it. Number 6. A full NASA spacesuit costs $12 million. Take that, Hype.
I think it should cost more than, I ain't even mad at that. I think it should cost more than that though. You know what I'm saying? Like, you don't get no mess ups up there. Everything that they're required to do, and like I was saying earlier, if something goes wrong, they also got to turn into a mechanic and figure it out. So yeah, that suit should cost $1 billion. I don't care, whatever they need at this point.
Fashion designers, for once, a piece of clothing that is actually worth its insanely high price. I mean, at least a spacesuit keeps you alive, in space. NASA's current fleet of spacesuits was reported to cost between $15 and $22 million in 1974. Today, that would be about $150 million. And having not delivered any new mission-ready extravehicular suits since then, for obvious costly reasons, NASA is running out of spacesuits. In fact, they're down to just 4 flight-ready EVA suits.
And it should be easy to operate. Very easy for them to operate. You know what I mean? Like, easy enough to where a kid could do it.
Don't think they're being lazy or stingy. Not at all. In fact, NASA has invested more than $200 million since 2009 just for spacesuit development. And they did unveil the X-Emu prototype, but they haven't yet delivered a new fleet of spacesuits. But how come they're so expensive? Well, when you think about a spacesuit, it's better not to think about it in terms of work clothes, but in terms of a personal, human-shaped spacecraft. They're very complex, and they must protect the astronaut from the vacuum of space, the radiation of the sun and other celestial bodies, and against fast-traveling particles that sometimes can travel up to 18,000 miles an hour. You can imagine how tough it is to build something so resistant, yet that allows the astronaut to move. The suit also must provide oxygen, communications, telemetry, and everything else that a human being requires to survive. And all of that rolled up in one tiny human-formed spacecraft. Number 5. Ice volcanoes. Cryovolcanism. A cryovolcano is an extraterrestrial volcano of ice and water. Despite the low temperatures and materials that make up and expel cryovolcanoes, their basic structure is virtually identical to molten rock volcanoes like those on Earth. This shows that volcanoes are not necessarily formed by high temperatures, but by considerable temperature differences. In this case, the low temperature of the ice with the slightly higher temperature of the water, just over 0 degrees Celsius. In them, liquid water plays the role of magma or lava, while ice plays the role of rock. Cryovolcanoes form on the icy moons of glacial and gas giant planets, and probably on other astronomical objects with very low temperatures, such as those in the Kuiper Belt or the dwarf planet Ceres. They are possible thanks to the diverse range of temperatures in space. In this case, the low temperatures of the satellites of distant gas planets. Instead of lava, these volcanoes expel volatile elements such as water, ammonia, or methane. These generally liquid substances are called cryomagma, although they can also be in the form of steam. After the eruption, the cryomagma freezes solid due to the low temperatures of space. This is analogous on Earth to the solidification of lava. Number 4. Shrinking Mercury. The planet Mercury has shrunk about 7 kilometers in the last 4,000 million years.
Now that's odd to hear, something up there shrinking as well. No, it's not odd to hear because we were hearing other planet. What was it, Saturn? That was growing in height but not in width. I think it might have been Saturn. I can't remember. I have to go back and check now. They over. I mean, my brain is just overwhelmed with all the information they're throwing out in this video. Great stuff though, by the way.
3 times what scientists estimated until now, according to research published in the journal Nature Geoscience. The study, led by the astrophysicist at the Carnegie Institute of Washington, Paul Byrne, suggests that the geological structures observed in the crust of Mercury are the result of a pronounced contraction due to the cooling of that body. Byrne's team has analyzed the ridges and faults on the surface of the planet closest to the Sun through images taken by the MESSENGER probe, in orbit around Mercury since 2011. Using the information from the MESSENGER, the researchers have recalculated the displacement suffered by the crust of Mercury, a planet that rotates so slowly on itself that its solar days are as long as half a year. It's also an extremely dense planet, with a large iron core of 2,020 kilometers in radius, while the mantle and crust measure only 420 kilometers.
I know 24 hours in a day ain't enough, but what they just said is ridiculous. That's way too long. You'd be ready for that day to end. That's like Groundhog Day.
According to scientists,
the movie,
the geological structures that can be seen on the surface are fractures and deformations in the lithosphere, the rigid layer of Earth that covers the rocky planets. New calculations of Mercury's contraction place that decrease in its radius in the last 4,000 million years at about 7 kilometers, while until now it was thought that this decrease had been between 0.8 and 3 kilometers. Number 3. Why do stars twinkle but planets don't? If you look at the sky on a clear night, you can see how an infinity of white dots fill the sky. And if you look even more, you'll notice how some seem to blink and others do not. What's the reason for this? Well, first of all, we have to say that stars are the only ones that twinkle, while planets remain as fixed points in the celestial vault. The reason why we see stars twinkle is due to the distortion that our atmosphere produces on the light rays that reach us from them. As the light from a star passes through each of the layers of the Earth's atmosphere, it refracts and changes direction, since each of these layers has turbulence, different temperature and density, which is why the light seems to flicker. This is a headache for astronomers because this distorting effect of the atmosphere, called seeing, affects observations of astronomical objects.
They just ruined my childhood with that information.
Which is why the Hubble Space Telescope was placed in space. Planets, on the other hand, appear as larger dots and do not twinkle, because being closer to us than stars, they have a much larger surface and beam that is unaffected by these disturbances. The curious fact is that if we could see the stars from space, their light would remain stationary since we wouldn't have the influence of the atmosphere. Number 2. the largest, oldest mass of water in the universe.
Really?
A team of international astronomers has recently discovered not only the oldest mass of water ever detected in the universe, but it turns out it's the largest as well. The newly discovered mass of water is a cloud of water vapor, and it's equivalent to 140 trillion times the water in all of Earth's oceans. It's located more than 12 billion light years away from us, and it surrounds a supermassive black hole feeding a quasar. But how old is this cloud then? Very, very old. In fact, because the light we're seeing from Earth left the quasar more than 12 billion years ago, we're seeing that the cloud of water vapor was present only some 1.6 billion years after the beginning of the universe. This discovery pushes the detection of water 1 billion years closer to the Big Bang than any previous find. This is yet another demonstration that water is pervasive throughout the universe, even at the earlier stages. Number 1. Black hole and quasar. Quasars are the most luminous, most powerful, and most energetic objects in the entire universe. They're powered by enormous black holes that suck in any surrounding gas and dust and spew out a massive amount of energy.
I think black holes is like one of the most scariest things in space. Every time I hear it, I just,
difficult to imagine how incredibly powerful quasars are. To give you some perspective, there's a quasar called APM 08279 plus 5255, which harbors a black hole 20 billion times more massive than the sun and produces as much energy as 1,000 trillion suns. These numbers are so inconceivably vast that we can't really picture their immensity. It's quite poetic in a way that the most luminous object in space is fed by the only true invisible object in existence. It is the eternal dance of darkness and light. I don't know about you, but I had no idea that the universe is such a complex and unpredictable place. What about you?
Not at all. Any information I receive, you know what I mean, about space, I'm always willing to sit down and listen to at that point because it's just super fascinating to me, bro. Super fascinating. And there's still more to come. We just checked out that video yesterday that was getting signals, still receiving signals that we have yet to identify. So, man, the more information, you know what I mean? But like the title says, I don't think it is the fact we aren't ready to hear it. It's just some of us are in our own little world, man, and we don't think about that type of stuff. But I want to hear it. I want to know. I want to know. I'm interested in it. You know what I mean? But y'all get at me in the comment section. Let me know what you think. All right? And stick around and stay tuned. To the next one, I'm gone. Peace.